I think it's recording. Can you see it?
Wait. Okay.
Yeah.
Okay. Hi, everyone. I'm Kelly, and I'm the facilitator this week. Does everyone want to say their roles?
Okay. Ariel and I are the data recorder and graph constructors.
I'm production person.
Megan and I are the CDSU people.
Okay, perfect. Okay, so this week we are doing Earth and Space Science one. Has anyone read over the experiment already? Kind of.
Yeah.
I had a brief look.
Megan, your mic's off.
Yeah, I can't hear you, Megan.
Oh, sorry. There we go. I said no, I haven't, because they told us not to.
Okay. That's
all
fine.
fresh.
Okay, so I'm just going to read through the description thing. So there's two parts to this activity. So in both of these activities, you will model and explore the distance and size of planets within a very small section of our solar system. These are modeling activities / demonstrations rather than full investigations. Even though you won't have to think about what the variables are, you can complete other processes such as predicting, understanding and H&S for the activities, understanding the activities fully before you complete them, then the assigned roles, etc., etc. And we have to write 3 points to communicate the patterns, and then turning that into 1 to 2 observational sentences. Okay. So pretty much the first demonstration is how big are the planets in our solar system, and we're using them with fruit sizes, which will be interesting. And so it's just what the sizes are, comparing them to each planet. Mm-hmm. And then the second demonstration is the order of the planets along the solar system, in the solar system. So firstly we'll talk about Akara and how it relates to that. So I got it up, and Earth and Space Science, it says year 5, it says the Earth is a part of a system of planets orbiting around a star, in brackets the sun, which I thought that would probably match the best. What do you guys think?
That sounds good. Spot on.
Yeah. Okay. So we'll start with the first demonstration. So the 2 questions are, how big are things in our solar system, and predict the size of each planet in relation to these fruits. So I'll go through the...
Hey, Kelly, was there any health and safety you needed to go over with this one?
I thought we could do that all at the end.
Perfect.
We'll talk about that at the end. Yeah.
Perfect.
Okay, so this is what I had to get. I had to get a grapefruit, a lime, 2 cherry tomatoes, a blueberry, an apple, and a peppercorn, which is just a little thing of pepper.
Oh my gosh.
And I was meant to get a watermelon, but I didn't, so I'm just using a ball because it'll be the same size.
Yeah, perfect.
Yeah, okay. So I'll go through the steps of the demonstration. So the first step is ask anyone if they can remember something from school that you got taught about the solar system. Can you remember a song or anything about all the planets, or do you guys have any knowledge about what the planets are?
I remember the song where you just remember all of the different planets, where it was it wasn't really a song, but it was kind of when you go Mercury, Venus, Earth, Mars, you go through that. That's pretty much all I remember.
Yeah, I don't really remember having a song, but
I remember we made paper mache stuff in year 5, I think it was, and we made our own solar system, but using paper mache and balloons.
Oh yeah, that's
So that was
cool.
pretty cool. And like we got to paint it.
Okay,
I
so
remember, like hanging it up. Like I feel like we had like a coat hanger and we
Yeah.
would like hang it up and we like put like the sun in the middle and like showed all the planets like around it, like kind of like a mobile, like for a kid kind of thing.
Yes, that's
Yeah,
what
I'm
I
yeah.
mean.
thinking that. Yeah.
Yeah.
all right, well that's good. So now I'm going to see if you guys know the names of the planets.
Oof.
So I write them each down on a post-it note, and we just see how you guys go with that.
The Earth.
So Earth,
Earth.
that's
Sun.
a good start.
Should Megan and I shouldn't probably not do this because we've got the CDSU
Yeah, we'll stay out
and
of
we
this.
know it all.
Yeah,
Okay. Yeah, did you write Mars?
Mars,
Venus.
Venus.
I know one of them isn't classified as a planet anymore.
Is that Pluto?
I think so, yeah.
That's
Yeah,
the only one
not on here.
I knew.
Anyone else?
Mercury.
Yep, Mercury.
What's I actually don't know.
There's 8, so there's 4 more.
So we've said Earth
We said Earth, Mercury, Mars, and Venus.
and Pluto doesn't count.
Jupiter.
Yep.
Oh,
Jupiter.
yes.
Is it like Saturn? Is that?
Saturn. Yeah.
Yep, yep.
I'm just like,
Jupiter.
And Uranus.
Oh, Uranus. Yeah. I feel like everyone should
Say it properly. Or else you get in trouble.
have.
Okay, is that 8? Oh, we're missing 1.
Missing one. And the sun doesn't count.
The sun doesn't count. It starts with an N.
Neptune.
Ah, yeah.
I thought I said that. Maybe I didn't.
Okay. So, you guys did well. Okay, now we're gonna look at the fruit, and then you guys have to guess which planet you think matches the fruit. And then we will do our initial hypothesis of that, I guess.
Okay.
Okay, so okay. So these are the fruits. There's this big one, the apple, the lime, the grapefruit, the cherry tomatoes, and blueberry and the peppercorn.
And the basketball, the netball isn't the sun.
No. So does anyone want to start with this one? What do you think this planet is?
I reckon it's
Biggest.
Mercury.
Do you guys want to say Mercury?
I thought Mercury was small. I don't know why, but I feel like it was going to be a littler one. Because I know Pluto was on the outside, and then I thought it was either Saturn or Jupiter.
Yeah,
Yes, it's Saturn.
if we start with this, so we'll start with one end's the sun, and then the next one will go the fruit and what planet you think that is.
Wait,
Probably
so
sun.
So that we'll just put it in a line.
as
But
in
like
the sun. Oh, we're putting in the order or the size order?
it's just like it says so this is what it says. It says choose an end that represents the sun and one at a time as a group discuss which fruit relates to the first planet and why. Continue asking these questions until all the fruit has been allocated and is now in a line.
Okay, so the one closest to the sun.
Yeah, so what fruit do you think that is? And what, yeah.
So the size of the fruit will tell us which planet it is.
Yeah, are you going to give us a hint? Are you going to give us...
Well,
Does the smallest start off?
It says you're meant to guess. It says you're meant to guess.
Okay. What planet is closest to the sun?
I thought Mars was closest to the sun.
Okay, Mars. But Mars, you're saying isn't the biggest.
Yeah. So
No, I
what
thought
I reckon Mars is that orange thing.
this?
Yeah.
Okay, we'll say this is Mars.
That's what I think.
Okay.
Vincent and Megan know, right?
Yeah.
Yeah.
We can't
Just
say
laughing
anything.
at us.
Don't spoil it.
I thought it went Mars and then
I don't
Is it
think
the
Mars
Earth?
is.
Venus or Mercury, and I thought Earth is I thought third or fourth.
Third. Yeah.
Okay. So what do you think's next? Like what fruit? With what?
Wait, can you tell us if it goes the smallest to the biggest from the sun?
Well, they're all different sizes. Like it doesn't go in size order.
Okay. So
Okay. I think.
we are saying which the next planet is, and we pick which fruit.
Yeah.
Okay.
I reckon it's Venus.
Yeah,
Venus?
let's go with Venus, and maybe Venus
The
can be
line.
one of the little
Of the
thingies.
little things. Okay. The cherry tomato.
The
Tomato?
cherry
Okay. What's next?
Earth is third, isn't it?
Earth.
Earth? Okay. What?
And cherry tomato.
Do you reckon it's little as well? Okay. I actually have no idea, to be honest.
Okay, what's next? So we've still got the apple, the lime, blueberry, the peppercorn, and the ball.
Have we said Mercury?
Yeah.
No, you haven't said mercury yet.
Oh.
I think Mercury is going to be a little one. What's like either like the blueberry or the pepper thing?
I reckon blueberry.
Okay.
Yeah, let's
What do you think the peppercorn will be then?
I reckon the peppercorn will be Neptune.
Okay.
Okay.
What are we missing?
So you still got Jupiter, Saturn, Neptune, and Uranus.
Jupiter, Saturn. Which one? Jupiter, Saturn, Uranus, and
Neptune.
Neptune.
I thought Jupiter and Saturn were the biggest ones.
Okay. Let's do Saturn, the big one.
Okay, the ball.
Yeah.
Ball and melon.
And I reckon he's there.
Mhm.
What do you guys think?
Yeah, okay.
Yeah.
Okay.
And then Jupiter, the next biggest fruit.
Jupiter next. So you've got the apple or the lime. The apple?
Apple.
Yeah.
I reckon we're gonna be so off.
And then we've still got
And
Neptune
then
and Uranus. So you've got the lime and the little pepper.
I reckon the pepper goes next, just to spice it up.
Yeah.
But do you reckon Uranus is the lime, and then what's the last one? Neptune.
Yeah.
That's the small one. Is that what you thought, Mary's?
Yeah.
Okay,
So-
we'll just
But do the pepper now and then do the lime after the pepper.
Yeah.
So Neptune now.
Yeah.
Okay.
oh no.
Okay. So I'm gonna take a photo of that to document.
Wait, did we put the blueberry next to the big one?
Yeah.
That's right. We just go with it.
Okay.
Does
So
this count
that,
as our initial hypothesis?
Yeah, this
Yeah.
is going to be our initial hypothesis. So if we want to, does someone want to type it and we'll think of one? Okay.
Well, if you send the photo as well, we can probably use that in the graphing as well.
Okay, yeah. I'll send it after. Okay, so what's our initial hypothesis? What do you guys think?
Probably just what order we said they were going in.
Yeah, so we would say you pretty much just have to say the fruits and what planets you said they were.
Yeah.
Okay, so we
If
can
you
use,
send the photo, can we just put that in there?
yeah, we could just type a little thing under the photos maybe.
Yeah.
Okay.
Do you want to read them out, Kelly, from from the closest to the sun out of what we've got?
Okay, so
Yeah.
the sun, and then you've said Mars is the orange, Venus is the tomato, Earth is the tomato, Mercury is the blueberry, then you got Saturn as the watermelon, then Jupiter as the apple, then Neptune as the peppercorn, and then Uranus as the lime. Cool. Okay, so
Seems like that's so wrong.
now I'm going to put it into the correct order.
Okay.
And then you guys are going to say, like, what surprised you. And, yeah. And we'll have a discussion about that. Okay?
Alright.
So first it goes Mercury with the peppercorn.
Oh.
What size did we say Mercury was?
You said Mercury was the blueberry.
Oh,
So
close.
Oh, well, yeah, we weren't
Pretty
far
close.
off.
But that was
And then it goes Venus as the cherry tomato, which you got that in the right.
Hey, that's good.
And then it goes Earth with the cherry tomato, which you got right as well. And then it goes Mars with the blueberry.
Mm.
And then it goes Jupiter with the bull. So it's not Saturn. You guys said it was Saturn, but it's Jupiter.
I said either.
Saturn is the orange. And then Uranus is the apple. And you said Uranus was the lime. And then Neptune is the lime. So you didn't do too bad.
That's all right.
Yeah.
So what surprised you guys? Did anything surprise you guys?
What was the blueberry?
The blueberry was Mars. And you had the blueberry already next to the ball, but you said the blueberry was something else.
Yeah.
So that was right.
What's the
I
one?
think something. Oh, sorry. You go.
No, you're right. You're right. You go.
From like already knowing the CDSU, because like Vincent and I did it, I found it super fascinating that you guys put Mars as the one closest to the sun. Because if you think about it, like that's where we send people, that's where we send rovers. That's like where Mars, I feel like, has been the most explored, and you guys put that really close to the sun, which I found really fascinating.
I think for some reason I had this thought that Mars was always really hot.
That's what I thought. Yeah.
I feel like that's fair because, like, you see on TV that it's like all red and it's like
Yeah, the red probably. Yeah, you're right. And
yeah,
that's an alternative conception then, if you want to like bring that into it with the color of it and stuff.
And I don't think I thought about the other planets. I always thought about the main ones like Mars, Earth, Jupiter, and Saturn, but I didn't think about the other ones, like little ones.
yeah. What about Mercury? Because that's like the smallest peppercorn, and that's next to the sun.
I kind of forgot about Mercury.
I literally was just about to say that. Yeah.
Yeah. Yeah.
But
And Jupiter is the big one.
Yeah. And then it goes Saturn after that.
Yeah.
Yeah. I think I got those two mixed around in my head.
Yeah.
I didn't know which was which.
So, if the sun, like, what do you think the size of the sun would be in relation to these fruits? Like, if it was a fruit or like if it was something else, how big do you reckon the sun would be? And why do you think that?
A lot bigger.
What would like represent it?
Maybe
you know those big
the inflatables.
the inflatable things that you run in.
Like bubble soccer kind of things.
Yeah.
Yeah,
Oh,
that's
yeah.
what I reckon the sun would
Yeah,
be.
that's a good one. Yeah. Okay, so then our final hypothesis would be what is the correct fruit to the planet, I guess, and why. Okay, so I'll take photos of this. Is there anything else you guys want to mention before we go on to the other one?
Maybe Rose, did you have any thoughts about the graph?
No, I just think that's really good if you're introducing it to the kids.
Yeah.
It's a good activity for introducing the topic
Yeah.
and like understanding what their prior knowledge is, and then using the CDSU to actually like educate them on it.
Yeah.
Yeah.
Because
Yeah, I think that's really good.
this one's like, I just had to let you guys guess, and I couldn't really like say much.
Yeah.
Best way to find that prior knowledge, though. I think that's so good.
Yeah.
But remember last year they taught us like that's what you have to do.
Yeah.
You have to see what they want, what they know already, and you have to do it in a way that you can't tell them yes or no.
Yeah.
So it's good.
Yeah. I feel like it was pretty fun, like to try guess with the fruits and stuff too.
Yeah. And they could do it a bit more hands-on rather than like they could move them around themselves.
Yeah.
Okay, so we'll move on to the second one, and then we can have a big discussion at the end on everything else.
Perfect. Mary Rose, are you typing into our document? Did someone do like our initial hypothesis, or are we just saving that for when we get the photos?
I think Molly wrote the initial hypothesis.
Cool.
Yeah, I'm just gonna add
I'm
the
just-
after.
Yeah, I'm just typing what we can do for our graph. So I just said like we could somehow represent what we thought they were in the beginning versus what they actually were.
Yeah.
I'm just trying to think of a way how we could do that.
Okay. So the second activity is the distances of the planets. So the questions that it poses is, what is the order of the planets? If the solar system were to be scaled down to a radius of 30 meters, predict the distance of each planet from the sun. So firstly, I had to draw a 30 centimeter line just on this piece of paper. You can't really see, but there's my sun, and then I had to put Neptune at the end. And so we have to predict where you think the planets are located along the centimeter line, and we have to write down each, like what centimeter you think each planet is away from the sun. And then I'm going to put little post-it notes on the 30 centimeter line on where you guys think each planet goes, if that makes sense.
Okay.
So and we also have to explain why we think each planet goes there and why we think that distance. Okay, so we'll start with Mercury. Like on a 30 centimeter ruler, where do you think Mercury would be placed?
Seems pretty close. Like maybe a centimeter away, or like a couple centimeters.
I reckon, 1.5 centimeters.
Yeah.
1.5. Okay. Okay. Now Venus. That was our cherry tomato. Where do you think that is in relation to the sun? On the centimeters.
I feel like it's like a bit away from the last one, and then the like next two will be close together.
So, because you said Venus and Earth would be the two cherry tomatoes.
I
Are
think
those
they're
ones?
close.
Okay. So, what centimeter do you think?
5.
From the sun?
Yeah.
Yeah, from the sun.
Yeah, 5.
Are we gonna have enough room for all the other planets though?
Yeah, remember there's 8. We have to do 8 on 30 centimeters.
But I think that these two are really close together,
Mm.
and then like a centimeter away from the next one. But
Okay,
that's-
so what about 3 centimeters
okay.
from the sun? So then it's, because the other one's 1.5.
So do we go? Yeah. Is this to to see alternative conceptions as well?
Yeah, this is like similar.
Mm.
And then we'll go outside and do the 30 meters and place them on there. Okay, next is Earth. So you think that one's going to be really close to Venus. So what
No, I
centimeter?
don't know, because then is it too close to the sun?
Do we think a centimeter away from the last one?
Yeah.
So we'll say 4 centimeters.
Yeah.
Yeah.
So what have we got already?
So we've got Mercury at 1.5, Venus at 3, and then Earth at 4 centimeters. I'll show you what it looks like so far.
That's okay, yeah.
They're all pretty close so far.
Yeah. So we'll start spacing them out a bit more now.
Yeah. Okay, so the next one is Mars.
Well, it can't be too far away from Earth because if they think they might send people there.
I reckon 2 centimeters away.
2
From
centimeters.
So I reckon 6, 7 meters away from the sun.
Okay. So next we have Jupiter, which was the big one. So where do you think that would be?
A bit further, do you reckon wait, how many centimeters do we have from Mars to what's the last one?
6 centimeters.
There was 2
Like
centimeters difference.
What did you say?
There was 2 centimeters difference between Earth and Mars.
I mean, how many centimeters from Mars to the last one?
To the sun or to
To the other way.
to Neptune?
Yeah.
So that's 24 centimeters away.
They've still got 24 centimeters for 3 other ones.
Yeah.
All right.
For,
Do you wanna-
for 4 other ones, including Jupiter. No, for 3 other ones.
Yeah.
Sorry.
Yeah. Do you want to say 6 centimeters from Mars? So 12
Yeah.
centimeters from the sun?
So you think it's a bit further away? And then we've got Saturn, which is next to Jupiter.
What do you guys reckon?
I reckon 3 centimeters from Jupiter.
Okay. So that will be 15. Okay, now we've got one more, which was Uranus, and we've got kind of a big gap.
You just want to go in the middle of that?
Yeah.
I don't know. Honestly, I actually have no idea. To be
You can go 22 centimeters, 21 centimeters.
Yeah.
All right.
Yeah.
Okay, so we've got that locked in. So this is going to be our initial hypothesis again. So I'll take a photo.
What did we say for the last one?
21, 22.
22?
What was
Yeah,
it?
22. This is what it looks like.
Hmm.
Too bad. The first ones are really close.
Okay, so once we have locked in the information, we're going to plot our ideas about the planet's distance from the sun using the 30-meter tape. So I'm going to go outside now, I guess. Did you guys find that one hard?
Yeah, I had no idea.
Confusing.
Okay, this is really difficult. So hang on, let me run up here. I've got a sensor light, so I need to.
Are we learning about the orbit or the temperature?
I don't think so.
No, okay.
Vincent and Megan, you're muted again.
I've got a little bit of stuff, like Vincent, I've got a little bit of stuff in CDSU that's not directly like about distances and stuff. So like some fun facts and things. So
Okay.
Yeah, so I think we worked together on this, but have you read the thing, Megan and Vincent? For the experiment, like the experiment thing?
I can't really remember what it says, but
Because
I briefly read it.
so once we plot our thoughts onto this line, we then change it and do the correct, and that's when you guys, the CDSU, like we work together and
Okay,
you explain
cool.
these planets and yeah, okay.
yeah, cool.
So I need my tape measure. Okay. So we said Mercury was at 1.5 centimeters, which is 1.5 meters, right?
So do we do our initial hypothesis first and then the actual thing?
Well, this is like our initial hypothesis is what you guys thought the distance was from the sun.
Yeah, but are you just putting the real one, like what the actual one is, out on the line?
No, I'm doing your one out on the line now, and then we do the real one.
Okay.
But it's kind of hard because it's like really dark.
Yeah.
So I'll try and show you. I'll use my torch as a flashlight. Okay. So here, that's my sun,
Okay.
and then the line starts, and it goes all the way up the top of that driveway. But that's a sensor light, so when we go up there, the light will turn on for us. But okay, so I'm just gonna use the post-it notes. Okay. I wish it was light, but what you can do about it. Okay, so we said Mercury was 1.5 centimeters, which is 1.5 meters. So I got my measuring tape, and I'm just going to put it along here. I'm just going to put the sticky note, Mercury sticky note, onto the line.
Oh, it looks so difficult.
Yeah, I was just thinking that. Poor.
Okay, here's the sticky note. It's going here. Next we said Venus was 3 centimeters, which is 3 meters. So I already got my 3 meters marked here because I had to use, I didn't have, oh yeah, I probably should say that. I didn't have a 30 meter tape measure, so I just used 3 meters. And I had to mark it out all the way, so that was fun.
3 meters of what'd you use?
Like a 3 meter tape measure.
Oh, sorry, yeah. But did you use a the string? Did you end up using that?
So I had to use a power cord because I didn't have rope that was long enough.
That's good.
Very resourceful.
Yeah.
A power cord, and then yeah, I marked it out like that way. Okay, next we have Earth at 4 meters. Can you guys see me? Yeah. And then we had Mars. Mars at 6 centimeters.
Bless me.
Bless you.
Excellent.
Jupiter at 12 centimeters. So it's pretty far distance. I'll show you guys at the end though, but from Jupiter to Mars, it looks really far on like a 30-meter line. And Saturn 15 centimeters and Uranus 22. Sensor light isn't turning on, but
At least it'll be daytime at the school.
yeah. Okay. So this is what the line looks like. So we've got that's that far from the sun. That's Protein right there. And then we've got all the way down here. And then that's Mars. Can you guys see this? That's
Yeah,
Mars.
yeah.
Yeah.
And then all the way here is Jupiter. And then we've got Saturn. And then up there is the next two.
It's your
Okay. So next we put them into the right place, and then oh yeah, so it says, do you guys want to change any of your ideas now that you see it represented this way?
I probably would space the the first one's at just a tiny bit, but probably not like worth changing on that. But I actually have no idea, so
Let's just move on. Okay, so this is where it says roll 2 and 4 work together for this next part. So we place the correct planet at a time, starting with the planets closest to the sun, and discuss the following questions about each planet before moving on to the next planet. So the CDSU, you guys, do you have it up? Because it says, ask, imagine living here, what would the weather feel like? Explain why you think this. How long might a day or a year be like? And explain why you think this. So while I plot, while we plot them in the correct distance, that's when you guys talk about the CDSU.
Is everyone guessing and saying what they think first, and then we tell the CDSU? Like, are they guessing what the temperature might be like, or are we just telling them?
Well, it says that you ask the question and say, like, ask what they think it's like, and then just like why and stuff, and then so I'll plot it and then have a discussion about each planet, I guess.
Cool.
Okay, so we'll do the correct. So I already pre-marked my like power cord with permanent marker. So the first one we got pretty close. I'll get the distances. So the first, Mercury, the peppercorn, we said it was, I think we said it was 1 and 5 centimeters.
Yeah, 1.5.
And then the correct is the correct is 38 centimeters.
Oh.
So
38. 38 centimeters.
Yeah.
In a 30-meter scale, but so
It's
0.38 centimeters and the 30-centimeter one.
Yeah.
If you can see, that's how close it is to the sun.
Yeah.
And the sun's like that big, so.
Yeah, so it's next to it.
Yeah. Okay. And then next we should talk about Mercury now, if you guys want to. CDSU.
Yeah. So, what do you guys think about Mercury in terms of like climate, like what it's like, what it would be like to live there, kind of thing? What are the the questions that she's hot? Yeah.
Yeah, I think like obviously no one can live in it because it's too close to the sun.
Yeah.
There would be no water. Yeah. And
obviously we know it's peppercorn, so it's like a lot smaller.
Would it be longer days or shorter?
What do you think?
Do you think it would just be like sun all the time?
Yeah, I don't know.
Because I feel like in my head I just see like the ones that are closer would have a lot more sun, and then the ones further out would be really dark, obviously.
Yep. So, little bit of the temperature, the average daytime temperature on Mercury is about 430 degrees Celsius.
Oh.
Wow.
Like just the average daytime temperature.
Yeah.
And then also it apparently can drop to negative 180 degrees Celsius at night. So quite like a drastic
Mm.
in terms of days. So it's actually really long days and short years. So it takes Mercury to like spin around once 59 Earth days. One day on Mercury is 59 Earth days.
Wow.
And it makes its complete orbit around the sun in 88 Earth days.
And Earth makes its. Earth does one lap.
Yep.
So Earth, one orbit around the sun for Earth is 365 days. That's 1 year.
Yep.
Yeah.
But it's only 88 days for Mercury.
Yeah.
So it's shorter.
So it's shorter years by quite a bit.
Yeah.
Whereas like for Earth to rotate around once, obviously a day, 24 hours. But for Mercury to rotate once, it's 59 of our days.
Yeah, wow.
So really long days and really short years.
Yeah. Good.
Do we want the exact like distance from the sun? Are we going into that now?
Yes. Well,
Yeah.
I will
Yeah,
edit it now. I'll just get it up. Hang on. Sorry. Yeah. Okay. How far? It's 0.38 centimeters. Then
That's on a 30-meter line.
yeah.
Yeah. So according to NASA, which is what Vincent and I have been like using, it's about 36 million miles or 58 million kilometers from the sun.
Wow.
So another way that they're using it is they call it AU, which is actually, I'll get up exactly what it is. So it's called an astronomical unit, and basically the Mercury from the sun is 0.39 AU. But I have here 1 AU is like 149,597,871 kilometers.
What was that?
So this is 0.39 AU. So 36 million miles.
Wow.
Yeah. There's no moons and no rings. So sad.
All right. So next we had Venus, and you guys said, what did we say that was again?
3 centimeters.
3 centimeters, so 3 meters.
Mm-hmm.
But Venus is actually 72 centimeters away from the sun.
Wow.
So we had it here, but we're going to move it. Wait, wrong way. Move it all the way down to the sun. So
it's quite close.
yeah, so if you can see
Yeah.
how close it is. Yeah. If you guys want to take away Venus.
Venus is actually hotter than Mercury because it's just because of the atmosphere, because it's got a really thick, toxic atmosphere. It's filled with carbon dioxide and stuff, so it's just got basically big clouds on the atmosphere of sulfuric acid that just trap heat, and it just makes it like so much more hotter than Mercury. What's the distance for that one? So the average distance from the sun of Venus is 67 million miles or 108 million kilometers.
Have you guys heard anything about Venus? Like,
No, I wouldn't have expected that it was hotter. I would have thought it was just a little bit cooler.
yeah.
That's exactly what I thought as well. And like when I was doing the CDSU, that was probably one of the things that like surprised me the most, because I didn't really think about how all the different planets' atmosphere would really affect it. I just assumed if like the line from the sun out would just be the temperatures. So I feel like that was really interesting.
Can you guys see me, or have I gone?
You've just froze
Hmm.
on mine.
Okay, so next we have our Earth. And you guys said that was 6 centimeters. Did you say 6 centimeters? Yeah, so that's the Earth there. And then that's where the rest is, down there. So Earth is actually at 1 meter from the sun, which is pretty close.
Yeah. But it's so perfect.
Yeah, so
The temperature.
I'll try to show you so you can visualize how close it is. Can you see that?
Yeah.
So there's Earth down there, and that's how close it is to the sun.
So what is it in centimeters?
It's a meter.
Okay.
So it is actually, yeah, they're all quite close then.
Yeah, does that surprise you?
Yeah, well, I thought we were close. I thought if anything, we might have been guessing it was just slightly too close. But
Do you guys want to talk about Earth? Do you have anything to say?
Oh yeah, so obviously we know like a day on Earth's 24 hours, a year's 365 days. And then Earth is actually about 93 million miles from the sun, or 150 million kilometers. So, yeah. And then obviously we have one moon, no rings.
Yeah.
Mostly covered in water, things like that.
yeah,
That's pretty much it for Earth.
It's so interesting how our planet is like the only thing with life on it.
I know.
Mm.
Okay, so next we've got Mars, which is 1.52 meters, and you guys said it was 6 meters, but it's 1.52 meters.
so we were quite far away as well again.
So Mars is pretty close as well.
Mm.
There's Mars and there's the other.
Yeah, I think we said before, like, I thought it was really hot.
Do you still think that? Do you still think that it's really hot? Or do you think it's a bit cooler now that you know it's further away from the sun?
I feel like I'm second guessing myself. I think logically you would think it would be cooler just because it's just a bit further away from Earth. But maybe not. Maybe it has a different atmosphere again. I don't know.
Mm.
You tell me.
Yeah, so me and Megan found that obviously Mars is the most similar to Earth. So one day on Mars is only one more hour than Earth, so it's only 25 hours. And then a year on Mars is about 1.8 Earth years. And it's actually a very cold planet because it's got a very thin atmosphere. But we saw on NASA that apparently there is good evidence to suggest that it used to be really hot. But yeah,
It's
we're
like billions of years ago.
Yeah.
But it was like wetter and warmer, but that evidence suggests it was like billions of years ago. So I thought that was pretty interesting.
Yeah, it is interesting. Okay, so we've got Jupiter next, and you guys said Jupiter was 12 meters, but Jupiter is actually 5 meters, 20 centimeters. So Jupiter does look a fair distance away from where Mars was.
Yeah, I was gonna say that's crazy.
So here's Jupiter down here, and Mars is like all the way back up there.
Yeah.
So
in like specifics, Jupiter's about 778 million kilometers from the sun. So it's like quite a big jump. So like, as I said before, in like astronomical units, like Earth is only one astronomical unit, which is that like 149 million blah, blah, blah. But Jupiter is 5.2 astronomical units from the sun. Like in comparison from Earth, it's like crazy far away.
Yeah.
Yeah.
What do you guys think about the days and the years?
I reckon it will be longer.
Longer both?
Longer
Yeah.
days, shorter days.
Sorry, what did you say? Shorter days, longer years?
Shorter days and longer years because it would take longer to go around.
Yeah, you're right.
Yeah?
Yeah, so it's 10 hours to go to orbit around itself. So one day is 10 hours. But it's 12 Earth years to go around the sun.
It'd take a while.
So do you know how long it would take to get from Earth to Jupiter? Or is it impossible?
I think it's impossible, isn't it?
I don't know.
Neither. Okay. So next we said Saturn, and you guys said it was 12 meters. So, but it is actually 9.58 meters. So,
Are you writing this down, Mary Rose?
Yeah, I'm doing it. I'm doing a graph.
I've got some ideas, but we can talk about it later.
Some ideas for the graphs.
Yeah,
Okay.
but I hadn't written. I missed some of the numbers. So, but if you guys put it on the CVSU,
Yeah, you will have.
Yeah. We can share we'll share the document.
okay, Saturn, and then it's a fair distance away from where Jupiter was. So we jump.
Yeah, so it's almost double the distance away from Earth than Jupiter is. So Jupiter's about 780 and Saturn's about 1.43 billion kilometers. It's also sort of similar to Jupiter in that the day lengths are quite short. They're around about 11 hours is for one day, so how long it takes to rotate around itself. But again, like Jupiter, the years, it takes about 29 Earth years for it to fully go around the sun. The sun, yeah.
true.
Okay. So what's like the life like on there? Is it hot there or like cold there?
So Jupiter and Saturn are both classified as gas giants. So the atmosphere there is very warm, and yeah, the atmosphere is mostly made of mostly made of hydrogen and helium is the air, and the atmosphere on Jupiter and Saturn.
Okay.
I think the cool thing about Saturn, like, because Jupiter also has like a ridiculous amount of moons, but because of like Saturn's rings, they call it like a mini solar system, because of how it looks like with all the moons. So Saturn has 53 moons that have like been confirmed, but they're like trying to find confirmation of another 29 moons. So it would end up, if they all get confirmed, having like 82 moons in total.
That's
So,
great.
and the other cool thing was, even though like Saturn, because it's a gas giant, can't support life, they've found some evidence that some of the moons around Saturn like have like aspects of them that could potentially support life, which is pretty cool.
All right, we've got 2 more planets. We're nearly there. Okay, so next is Uranus, which you guys said it was at 15 meters, but it's actually 19.2 meters, which is a massive jump from 9 meters. It's like 10 meters difference.
Yeah. Where was Jupiter in the mix? Was that further out than
Jupiter, yeah. Remember, Jupiter was like a bit of a jump. from where Mars was. I'll show you guys again.
No, yeah, the one that's not a planet anymore. The Jupiter. I was just curious whether that was if it was in between that gap.
Jupiter was before Saturn, and
Ah.
it's like in between Saturn and Mars.
Yeah, sure.
So here's Uranus here,
Mhm.
and then all the way down there is where Saturn was. So it's like 10 meters difference. Yep. So what do you guys think Uranus is like?
Even colder?
Yeah, I reckon it would be freezing. And like it would be longer in the years.
Yeah.
Like really long.
And very dark.
Mm.
It's that
Yeah.
far away.
Nailed it, guys. So they call it the ice giant because it's like mostly made of like icy materials. Like NASA says it's mainly like water, methane, ammonia, and it's like got like this like rocky core. So it's also like a gas planet that has like hydrogen, helium, and a little bit of methane. But you're right about like the years being longer. So it's also got kind of shortish days. It's only about 17 hours for it to rotate around itself once. But it's 84 years, like Earth years, to rotate around the sun. So definitely longer year, like a longer year for them.
Yeah.
For them, like there's people there.
Yeah.
For it.
All right, so we've got our last one, which is Neptune, which we already knew that was at 30 centimeters because we knew that was at the end.
Mm.
So I'll show you. It's at 30 meters. When the last one was 19 meters. So it's jumped even further. So it's very far away compared to all the way down where we were at the sun.
Yeah.
Neptune, like Uranus, is also classified as an ice giant. So most of the mass is just hot, dense fluid and icy materials of methane and ammonia. It has a rocky core in the middle. The atmosphere as well is very gassy, made up of mostly hydrogen and helium and methane as well. Similar again to Uranus, there's shorter days, longer years. So a day on Neptune is about 16 hours, and 1 year is 165 Earth years. And it has 14 moons, and it actually has rings, but they're very, very faint.
There's rings and moons.
Yeah.
Okay, so I have to place all the fruits on the line where we said they were. Hopefully it doesn't roll down the hill, but yeah, so we'll place it along and then we'll just have a look at how it looks against the sun, and so you get a visual of it. And I'll take photos as well. So I'll quickly place them.
That's what I was thinking for me, our graph maybe as well. Like if we just had, it's very like, I don't know if you can see that, but if we just had the two lines with our initial hypothesis and then the CDSU, and then just place like little ones, we can see how far off we were.
I've pretty much messed up the data. Like I literally don't even know what I've done.
That's all right.
It's not good.
Yeah.
Okay. So what graph would we use for that then?
Just on Excel, we can just do a line graph, and then we can just make little planets and for the size one, I didn't really think it through because originally I had it like if we had our initial hypothesis and then the CDSU and then like going up, and I pictured it having a line, but I don't think that's going to work. So I'm just going to probably try put it on Excel and then make little planets and see what happens.
Yeah.
But I thought the second one would be easier because we can just have it set out in 2 lines and it'll just be really clear how far off we were. That like.
Yeah. So can you guys walk over what the actual lengths are for each planet?
Yeah.
All right. So wait. So do you want like the CDSU length or like the 30-meter lengths?
Is that in the CDSU already, Marius? Like if we get it just off the document?
Well, I'm not I don't know. Is it in there, guys?
Yeah.
Yeah. There we haven't. We like Vincent and I have our own Google Doc that we've been like collaborating on. But we can pop it into the right-hand side document.
Yeah.
Okay.
I can do that now. But yeah.
All right. Well, I'm just going to quickly show you. So. Oh, okay. Can you see that?
Yeah.
Okay, so there's this big sun. There's the peppercorn, which is Mercury. Then we had Venus and Earth, which is close to the big sun too, and they're both cherry tomatoes.
Mm-hmm.
And then we got Mars, which is a blueberry. And then we've got Jupiter, which is the big planet. And then we've got the orange, which is Saturn. And then we've got all the way down here the apple, which was Uranus, and then up the top, right at the end, was the lime, which was Neptune.
Mm-hmm.
So that's what it looks like. Do you find that interesting how small they are compared to the sun?
Yeah.
Like that little peppercorn compared to the big sun?
Yeah.
Okay, well, I'm going to take photos of this for you guys.
Cool.
Was there anything else we need to go over, or was it just health and safety as well? Or did you have
Yeah, I
other
think so. Are we not meant to go over those questions, are we, in this, or are we meant to? I'm sort of confused. I feel like everything sort of changed a bit.
Yeah. Well,
I feel like we can talk about the questions. So we're we're not
get asked.
We're not presenting, so maybe we should talk about the questions so it's in here. I don't know.
Yeah, why not?
Or do we not need to?
I don't know.
Too, but
I think I don't know. Well, I got some questions we can talk about.
Also, do we know if our LHS can be the same, or does it have to be different?
I think it can be the same.
Yeah, I think it can be the same.
yeah, she said it had to be different, but Ali had already said it could be the same, so I think she retracted that.
Okay.
Because that worked well last time.
Yeah, I like what you have.
It was nice and clear.
But yeah, we'll just make sure that we don't put any of the questions, like those main questions, because like from the first lot of feedback, I remember her saying you can just don't put them all there, but then now after our presentation, it's don't put them on there at all.
We could literally just even put do like an infograph thing, but just make 2 big columns on either side, and one would be science knowledge that we learned and one would be pedagogy knowledge that we learned. We could do little headings on each side to make it really clear that it's just science knowledge and just pedagogical knowledge.
Yeah.
Okay, so just quickly, our initial hypothesis for this was where we thought they were along the line, which I took a photo of like the blue sheet we did, and then I took a little bit of photos of like what we had placed before we changed it, and then our final hypothesis is just our observations and what what the actual places of the planets were. So got some questions. Do you guys think that's suitable for year 5? Like, would you agree with that?
Yeah.
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 Do you think like don't have to make it any harder, or like do you think that was like a good demonstration for?
I think we could hardly even get it, so I don't think it would be any harder.
Yeah,
Yeah.
I think it was really good, particularly like introductory thing to like wrap your head around it. Because like even like I was gonna say like when we first started, I thought the 30-meter line was like a bit ridiculous, and like to be completely honest, I was like, why are we even doing it when we could do it on that piece of paper like you did straight away? But then like watching you like leg it like all the way down that like 30-meter line, I was like, whoa, okay, I actually really get it now. Like, do you know what I mean?
Yeah, it's like 30
Yeah.
minutes are like a lot longer than I thought.
Yeah.
Yeah.
So how would you definitely do this as like a model demonstration for a class, or would you do it in groups, or like how would you guys do this?
It'd be good to be outside with the
Do it as a
kids.
class, I think.
Yeah.
Yeah. So like the teacher kind of runs it.
Yeah. I'd say, yeah, they could make predictions. Maybe they could do predictions in groups or predictions by themselves, because it's a good diagnostic to see where their knowledge is at on how big the planets are, where they are in our solar system, and how far they are from each other and stuff.
I was going to say they could maybe put like they could have their own post-it notes and write their name and the like planet and put it where they think it
do your
is.
prediction. Yeah,
That would
that'd
be
be good.
cool.
Compare where they actually like where it is. Leave those post-it notes there so they can see
Yeah.
Yeah.
they were.
Yeah, and obviously it would be like out on the oval. You would have like one of those, those measuring like
The rolly ones.
Wheels?
Yeah.
one
Yeah.
of those, and like it would be sunny.
Yeah.
I think you could also use it to check understanding. So maybe after you've taught the content as well, you could use it again
Yeah.
to like solidify what they've learnt.
Mm.
Do you guys have any like notice any cross curricular in it?
Maths.
Obviously.
Yeah, big one.
That was a big one. Yeah, so obviously converting the centimeters to the meters.
Yeah.
So health and safety, what do we have to say about that?
Look, it's fruits. I think it like if we were outside, it would just be like hats.
Yeah,
Water bottles,
Yeah,
and
some safety.
fruits. Yeah.
yeah,
Obviously, just like if everyone's like touching the fruits, we're gonna do the classic like don't eat it, don't drink it, don't use it as a weapon. I feel like that's just a classic for everything.
yeah.
But like particularly if like everyone's touching it, and then for someone to like germs and stuff, like
Yeah.
yeah.
Oh, sorry. So diverse learners. So how would we differentiate?
I feel like if visual impairment, they could you could get them to walk and feel how far it was, and then tell them when to stop, and that's where this is, and then walk.
Yeah.
Even like feeling the fruits for visual impairment, they can feel how different sizing is.
Yeah.
Yeah.
I think it's a really good like activities because they're so visual. So language necessarily like won't be as big of a barrier for like EALD and anything like that, because you can visualize it really clearly, if you know what I mean. There's not as much describing going on.
Yeah, I feel like if I didn't do this demonstration of like the sizing and like the distance, like I wouldn't really get it. Like you wouldn't really understand it, which was like this is good for. Yeah, so just like the use of equipment, obviously I used like a ball instead of a watermelon because I couldn't buy a whole watermelon. Yeah, and I didn't have the 30-meter tape, so I marked it out.
Yeah.
Yeah, so but I think schools should pretty much have
Every-
yeah, have a lot of that stuff. You might just have to like buy the fruit
Yeah.
for the class. Does anyone have anything else they want to talk about?
Really?
We spoke about left-hand side, the graphs, the CDSU.
Curriculum.
Yeah.
So I'll like send these where should I send the photos? Into the chat or something?
Yeah, that's
Yeah.
okay.
Okay. And then
And then we can just
yeah,
get everything.
write up what we need to from the photos.
If we can put the one in a OneNote, not OneNote, OneDrive again, that we can all access, that would be helpful. And then we can all just work on it together.
So do we have to do the right hand side as well? Do we know what we're doing for that?
Is that the
Yeah.
initial hypothesis and stuff?
Oh wait. No,
Do you mean the left-hand side?
yeah.
Mm.
Are we just doing a
Just the same as last week.
okay.
But
Do you just want to use Canva?
yeah,
Yeah, probably, yeah.
that worked well. It was nice and clear, looked good.
It was easy for us to collaborate on as well.
Yeah. Agreed.
Okay, well that's pretty much all I had to cover. So
No.
do you guys understand?
Yes, much.
It wasn't the best situation, but
You did good.
Made it work.
Yeah, you did.
thanks guys. Okay, well, is that everything?
I think so. Thanks.
All right, bye.
See you guys.